All right, for this Polarity and Solubility Discovery Lab, you can see your two questions here. And I'm starting to run out of time making this video, so we're just going to get right into it. With this, we've been talking about polarity, right? We can look at um, some, molecular structures that are pretty simple, right? Just a few atoms kind of bound together. But obviously, there are plenty more molecules besides those. Like you think back to biology, right? You talk about fatty acids and triglycerides and all these other, substances. Those do come into play a little bit with chemistry. So this looks, and again, you need to have your notes in front of you or just your lab in front of you because we're going to answer a few things on the pre-lab itself as we do this. So that's kind of complete and ready to go as we work through this lab. So we're focusing on whether or not something will dissolve. That's solubility. That's our focus here. So we're not concerned with whether or not how much it can dissolve as we look through. And as we get later in the video, I'll show you some technique things and what that like kind of looks like. Again, just do the two things really. Do they mix well together? Right. Not worried about how much they're mixing, just that they are mixing. Now, we've talked about polarity, right? We've drawn our simple molecular structures. There are some other rules that are associated with that. So while we're not going to use any of them, just good information, ionic compounds, right? Metals and nonmetals, or metals and polyatomic ions, right? They're ionic, right? They're transferring their electrons. And what we're going to be looking at are some more covalent compounds. And how can we talk about their polarity, even though they're covalent again? There's a couple extra rules that we can focus on. So if I look at this first one, kind of hydrocarbons. So that's something, again, really familiar in chemistry. So hydrocarbons here, sorry, really familiar in biology, I should have said, right? Really long hydrocarbon chains. So chains of carbon and hydrogen, and they have this formula CXHY, where the X is some subscript number. It could be 6, it could be 10, it could be whatever, again, that molecule is. And then the hydrogens can be whatever, again, number as well. But they're always, always, always going to be nonpolar. So like this molecule right down here, this is actually propane is what we would call this. So that is a hydrocarbon chain. There's three carbons, as we can see in the structure, with all hydrogens attached to each of them, all being their octet or the duet rule, right? Still all applies. But right, it's going to be nonpolar because of that, right? There's no imbalance of charge anywhere because of that. Right. So anytime we see something with a formula like that, it's just a bunch of carbons and hydrogens bound together, it is going to be a nonpolar molecule, right? And we'll kind of apply this shortly. Now, I'm going to change colors here. If the hydrocarbon, still that CH, has OHs or oxygen atoms, there's going to be polar and non-polar properties. So where that OH group, which is just a hydrogen bound to an oxygen. So if I look down here at the bottom right, this little structure for isopropyl alcohol, right, we can see this OH group right here, which is going to make this region polar, right? If we drew our partial charge, if we want it, but really just the polarity there because of that bond, right? Oxygen being relatively high electronegativity, hydrogen not as much. And then the rest is just kind of our non-polar region. So we kind of have something there where, again, where this, I'm just going to write NP for non-polar because I'm going to run out of room, but it's non-polar, right? Again, because it's a carbon hydrogen chain, but it does allow for this area right here to have some polarity. That's our major difference there when we add one of those OH groups like we did here, right? It kind of looks about the same as as propane does, but again, this hydrogen is replaced with an OH group. Right, that's one thing we need to look for because again, that can allow something to be um, polar, or at least have polar properties. And then we know from our conversations in class, what we've been looking at, we know that most molecules with any lone pairs of electrons will be polar. Right, so we've looked at a lot of those. Right, again, when we have a lone pair, that creates an asymmetrical shape, which then allows for polarity um, for partial charges to occur. Now, if we look at your lab, what we're going to be focusing on is what are our substances. So what you're going to do, and I'm not going to have you do, I'm not going to do all this with you, right? One thing you need to do as part of this pre-lab, and what I'll check, you need to draw your Lewis structure for water, right? I want you to draw that there, and then determine whether it's polar or non-polar. So you're going to put that and fill in those two. Now, the rest of these I'm going to work through relatively quickly, so I have time for the video here. Oops. So with that, we can look at again our rules here. This hexane molecule, once you decide, and you're going to answer this question on the side, is on the screen, multiple choice wise. You're going to answer that as well. So decide whether hexane would be something that is polar or non-polar. And again, you can check yourself when you're done. But if I move this up here, right, I gave you veg oil because veg oil is kind of weird. It's a really big molecule. It's non-polar mainly due to those hydrocarbon chains on the right side of that molecule. So if I look right here, okay. Now ethanol, right, and I'm looking at a hydrocarbon chain that has an OH group. So one thing I want you to do while you're working through this is circle that OH group, right? This is our OH group here. Otherwise, it's carbon and hydrogens bound together. Right, so the red part where I circled is polar, is a polar region. If you want to use different colors or if you want to just label whatever you want to do, it's kind of up to you. But then remember the rest of this is non-polar region. So it kind of has two regions where it's both polar and non-polar because again, the strength of this bond right here, the electronegativity difference on the OH bond really makes it polar because of that imbalance of electronegativity. Now, glycerin's a weird one, right? We've got all these really big OH groups again, and I want you to make sure this is again filled in your lab, right? So I've got those OH groups that I talked about. And because there's more of them, right? The one above it here, ethanol, only has one and it's kind of off to its one side, but we have these three that are really stacked together. That's going to make glycerin itself just polar. So we wouldn't include a non-polar region here because again, there are three OH bonds in this case. I'm going to show you a few technique things for our lab now. Main difference for this lab will be I will bring you all of your chemicals just because a couple of them are flammable and things like that, and just trying to keep everything separate so when you get set up for your lab, you're not spilling anything by accident. It's just kind of out of the way. So I'll bring this basket over to you. Right now there's only two things in there. There'll be a total of 5 things that you'll test with, but they'll all be labeled and things right now, but just so you can kind of get and see what's happening. The blue substance is water. So the water is going to be dyed blue. Just put a little bit of blue food dye in there, just because that's going to help us with this dissolving and mixing that we're trying to see in terms of solubility. So that's going to be in there, that's blue. Everything else will be labeled again. So just paying attention to the water being blue. So what the protocol asks for, you're going to have test tubes. You'll label them. Again, you'll have 6 total. So you would have those taped and labeled already if you look at your protocol, because again, you have your lab in front of you right now. But when it talks about dropperfuls, so these droppers will either be in the beakers or again, some of them will be in these bottles depending on the substance. So I'm going to fill that up all the way. And I'm just going to drop it straight down into the test tube. Be very careful not to touch the inside of the test tube because you potentially mix other substances, especially once you've added the water, right? We don't want to mix the water with other things that we're testing, right? So you're going to fill it, use 2 dropperfuls is what you'll do. Again, this is in progress. So you have about that much water in this case. Now, this other substance, I'm not going to tell you what it is, but again, if we're looking to see if mixing is occurring or dissolving, right, I'm going to do the same thing. I'm going to add 2 test tubes full, or 2 dropper bottles full, but again, being sure not to touch the edge of the test tube. And then I'll just grab another one. And again, just make sure you put the dropper all the way back in when you go to pick up the second dropper bottle, right? And then
what I would do, kind of lift the test tube up, give it a swirl, maybe 10 or so seconds, right? And again, what I'm looking for is whether mixing occurred. And in this case, right, we see that it did, because if I look at that, right, it's a pretty consistent solution, right? It's not, there's no layering. That's one key thing we can look for, is whether it's layered. But again, we're not worried about how much it's mixing or dissolving, just that it did, right? And if we mix it up, right, we can see that there's no, and you can kind of, again, either whether you hold your paper up to it, doesn't really matter. But we can also see that blue color kind of throughout. That's what the water's meant to help us with. So that's what you're gonna do. So you'll test once, then you'll do your next test and just kind of follow that same. It's a pretty straightforward lab, but you've got to pay very close attention to whether something is mixing or not mixing, and be very careful not to cross-contaminate with your dropper bottles and with your beakers, because again, some of the substances will be in these small beakers, some of them will be in these dropper bottles, but again, everything will be labeled. They're not right now because I don't want to spoil anything for the lab, but that's what you'll be able to use for this lab.